Okay, welcome back, everybody. I think this is episode 4. I'm probably gonna start losing track at some point. Um, and yeah, let's see. We left off. We fixed some of the issues with the dates getting in there instead of people, and did some async await stuff. And only thing I did in between was update the README. So now it's just a little bit clearer in terms of the setup, and I documented the reproduction steps, and that's it. So I think when we left off, it was actually, the thing was the data was still running, and it looks like it ended up being good. So if we take a look at the output, let's see. Take a look at the output here. We're downloading. Oh, right. I don't even remember what we're doing. So this was one of the outputs. And then the other thing we were rerunning at the time was to re-download people page views, I believe. Though now I'm realizing I never wiped. Let's see. I think it would. I think it would overwrite everything. Take a look here. We should see updated people page views. Right. Okay. So I probably should have just, because I'm not going to want these ones. I should have just purged the directory before I did it, but we'll just go, and we don't want these ones in the future. So it's actually just go ahead and look at anything that wasn't modified today, because that will actually tell us. Yeah, so these were all the weird issues that we didn't want. Anything that was overwritten or created new would be in there. Okay, so we're good. Next thing we have to do is rerun the join, I believe. So let's go ahead and check that out. And this time I will purge that. Let's see, I should actually probably do it. No, I'm not sure if let's see. I'm just going to do it manually. I don't think I'm going to bake it into the code. Okay, so let's look at the join script, make sure there's nothing we have to modify. Looks good. All right, so let's run it. npm run. What's that? ppd. No match. Oh. Let's see here. ppd. Oh, right, because ppd is defined here. I don't know what I was trying to log out. There's no match for D, is we want. Still not a good thing. Wait, D is not defined. For real. All right. Calculate. We're only looking at views and timestamp from traffic. So we actually want, what is person page view data? Let's look at a person. Well, we'll stop right there because that's not good. We don't want to be seeing no matches. So let's see why not. So this is supposed to be joining. Let's walk through this again. So we're reading this file, and then we're supposed to be looking for, let's say data for each, join data. So person is from the all death CSV. And then it's going to PPD. Right, it's gonna load in their file. Okay, so let's have a look here. Okay, well, the third one, Mario Cuomo. Let's take a look. Radical. So pages, first let's see if they're there. M for Mario. Okay, so that's the page view data, so that looks normal. And we should also see in all deaths. It's right there, that makes sense. And where is it logging? No match. No match. Oh, weird. This is just not a timestamp. That shouldn't happen. So, okay, let's look at Mario's 2015. That's great. Through 26. Also great. All right, so if there's actually no match, I want to return timestamp because that's honestly what it's checking on. So that's kind of weird. So let's run that again real quick. 2018 0626. And if we look at wiki page views, that makes sense because it's wiki page views didn't go through the 25th because we updated it today. So it's actually rerun wiki page views. So it's current. I didn't rerun it last time because I figured we had already done it. So this is interesting though. This is not inclusive, I think. Actually, let's see what happens if we run it. Let's see if it has the new one. Run. That seems crazy fast. That was amazing. Wiki page views. Still doesn't have it. Pump it up to the 27th, which is today. There we go. So it's not inclusive. And for some reason, the people article one, so if we look at get people page views, that one was inclusive. So I suppose that's good to know for the future. Inclusive. Exclusive. All right. Slack is back up, so I'm Slack now. All right, so we're good here. It should definitely never log out anymore. Okay, let's rerun it. Oops, wrong one. All right, so assuming that's gonna work, let's go back over here. So we were talking about last time is the next thing we should really do is try to figure out if we should who to include. So we have 1,400 people. We could pot everybody, but that's not going to make for a very interesting story. We really only want to plot people that move the needle. So I think we can start out by just kind of getting a sense of the page views. So first, I'm actually just gonna like look through a couple of people. So we'll start. We can start. Let's bring up that join file. And like, let's look at this person. And he was a Polish bishop. I can't imagine the page views are high here. So let's say the date of death was 2016, July 13th. So before then, he was getting single-digit page views for the most part. Let's see, 2015, yep. So if we go to July 13th, 2016, July, oh, there we go. Okay, so this is kind of interesting though, right? So this was kind of one of the projects. So it goes from single digits, goes into thousands, and then you see it slowly tail off, and it's kind of back to normal. Yeah. That's curious. So there's, I guess, a couple things I could think about. I could think about actual overall traffic, in which case someone like this person would not be of interest. Or we could think about kind of the percent change on the day that they actually do pass away. So clearly he saw a huge spike, but I guess there's probably a lot of compounding variables here. It's just like if his name is listed somewhere on like the 2018 death page or maybe on the front page of Wikipedia, that could be a lot of just kind of not fake traffic, but not organic really. So it's more forced. So we could calculate those changes. So basically looking at kind of the either the median or the rolling average of their page views before death. And then look at how much higher it went. So this actually like was 100 times higher than normal versus, let's look at what was Zito, who's I think a fairly well-known, let's find someone a little more prominent, Yogi Berra. So completely different story here, about 100 times more page views on average, it looks like typically. He passed away September 22nd. That is right here. And you see it jumps a lot. 500,000, 200,000. It slowly peters back down and quickly actually becomes pretty similar in terms of page views to it was before. Yeah. All right. So I think what we can do here is generate some more high level data. So I think we can go through, and I'm curious about that number we were just looking at. So basically the biggest their max compared to their median pre-death, I suppose. That's one number I want to calculate. So let's write that down. Calculate max median pre-death. What else do I want to look at? I guess just curious about like the raw number. So just the average median page views period for that person, I suppose. So then we can just get a sense of the 1,400 people and rank them. And then let's see. That might be enough to start just kind of poking around and seeing if we have anything. Yeah, okay. So let's start there. So we care about the views. And actually, we might do this as a percent traffic thing. Yeah, okay. Let's create a new I don't want that. Scripts. Actually, first let's commit is this. Join with post. So we're going to be doing something similar to the joining. We're going to loop through this thing, use this as our base. So let's just go ahead and copy that. And let's call this explore right now. That's what we're doing. We're going to explore. All right, so fs make derp 3 up with derp. All right, you don't care about that. You don't care about that or that. So we read in our data, and then let's just kind of calculate some things. But whatever. This is like, I call it a person. All right, so actually I should have not got rid of anything. We need to do this again. All right, well, let's start here. So a person comes in, we load, this time we load their join page, again, which is gonna have the daily information. So the daily data. And again, what we wanna do is just calculate a couple things for each person, which we'll do both the views and percent traffic. So let's see, const median equals it equals d3 dot median data views. We'll do that for, actually, first we need to clean this up a little because those things are going to be in strings, so we want to convert them to numbers. Return data.map. So return everything as it is, except convert a couple things to numbers. So views, and then the year, death. Are we using that? No, we're not using that. Really just the views and percent traffic. Views, d.views, traffic, d.traffic, percent traffic. And that should be it. So now it should be numbers so we can work with it. All right, sorry. Medium views, medium traffic. So this is for one person. Other thing we want to calculate is the, actually, let's just do this for now. So let's see. I guess we're using a link as the crosswalk. So we'll just return a new object for now. With link median views, median traffic. All right, cool. So that's going to turn a single thing, which will be a nice array, which means we can do with that's terrible. With yes. CSV. That works. And package. Looks like I should have done a progress indicator because I have no idea. Oh, that wasn't bad. All right, let's get rid of all this. Look at explore. That's not what we were looking for. Map, calculate. Well, first, let's just go ahead and slice on the first one. So then we can everything and we can get a sense of what this is looking like. Oh, that worked. I wonder why the CSV didn't. Undefined. Oh, because we didn't pass it the results. Slice so we can actually do this. All right. There we go. Not particularly interesting. Let's in order, so that's also not useful. Let's go ahead, and I don't think it's even necessary to write it out because we're just trying to look at stuff. So move alpha/explore. Let's do with averages sort. Ones. Let's start with views. It's not going to be much different. The percentage is just going to be like more accurate. Judge it, but I think this will be good enough for now. So we sorted it, and then let's just go ahead and log out. See what we're dealing with. Okay. So what this is telling us is that the most frequently looked at person that has died in the last 3 years is Stephen Hawking, Charles Manson, Muhammad Ali, David Bowie. This all makes complete sense to me. Definitely seems to pass the sniff test, except for this one. Let's see. Where the hell is it? There. Yes, this person is way bigger than I imagined. I'm not up to date on the rap game, apparently. Okay. But anyways, this seems to check out. I imagine if we did it by percent traffic, it's not going to be much different. Median percent traffic. Oh, okay, there we go. Okay, it looks just about the same. So that makes sense. All right. So that's kind of interesting. There's clearly a couple tiers here, right? We've got people all in the thousands. Actually, I'm going to go ahead and write this out to a file so you can look at everybody again. I changed my mind. What's that? Right file sync. / explore.tsv. Okay. That's not what we wanted. Format. All right. So we go from about 20,000 a day as the peak down to, because what makes sense, single digits. let's see where that kind of, so we're down to about, sorry, out of text sometimes. So yeah, it seems like pretty consistently going up. I'm seeing when I actually recognize the name. This is starting to get to about 1,000. All right, so if we cut it out, this like arbitrary 1,000-ish number, right? Looks like we get about 100 or so people. This is sorted by percent currently, so 0.00004% of traffic on a daily average. So like Yogi Berra, so he's totally recognizable, at least in the baseball world, and he's at like 107. So if I were to arbitrarily cut it off, I don't know, I'd probably look in the maybe the top 10%, 20% of people in here. But that also seems pretty arbitrary now. So yeah, I don't know. Let's keep looking. I was also going to look at, so that's median page views / traffic. And then let's look at the change of the max. So let's find the max for each person. Let's max views. Easy enough. Max traffic. Again, just so we have both options. What was that, like point at super low? Kind of those max views, max traffic. And let's go ahead and just this time look at it, sort by this will tell us who saw essentially the biggest spike when they did pass away. Only for a single day though, so it's not about the curve or the trend or anything like that. Okay, so on one day, that means Stephen Hawking got 7 million page views, which was accounted for 2.5% of all Wikipedia traffic that day. Stephen Hawking, obviously a couple notable musicians, and all pretty high profile people, I'd say. Okay, so basically both of these things, if I were using these to essentially determine the people I look at, these are both fine. They're gonna obviously tend to, I guess, put a spotlight on people that were already popular. So it doesn't give us any sense of people that kind of the rate of change that might have been more obscure and then were very noticeable for a little while. So that's why I wanted to also calculate that percent change. So let's go ahead and look at the people that saw the greatest percent change from their norm to that max day, and that's the simple division. So we'll also just add max change, which is for each max change views is max views divided by views, and max change traffic, and max says. So in theory, this will surface some of the less known people that had those kind of unlikely busts into the spotlight. I'm curious to see what that adds to the mix. And let's sort by that. Max change views. Cool. And I'm not surprised that this now kind of puts up a bunch of, at least to me, unknown people or lesser known people. Especially when we're going from 0 median views, that's not going to be very useful. So we maybe shouldn't use median, because infinity is always going to win. But let's see. So this person went from 14 and their max views, so they really jumped up. So actually, I'm not familiar with this person, so I want to actually come up. Wikipedia is what we want. Oh, awesome. Great person. Well, that'll do it. That seems to be, that's a very public death. Oof. So I actually want to look at that person's traffic more specifically. Hmm. One second, we're texting. Okay. So yeah, I mean, this is fairly interesting. He was, I mean, at least from a search interest perspective, was obscure, relative, almost borderline unknown before that. And then after his suicide, which garnered quite a bit of attention, it was up there for a while. And I mean, what was that? That was November 2017. Even a year later, over a year later, it's still getting quite a bit of attention. So that's pretty curious. Okay, so let's keep looking through that. So I'm not sold on any one direction of how to actually filter out people yet. I think I want to calculate some more numbers. I mean, that's a lot of, I don't think I can look through that many charts. But I mean, most of the people in here, unsurprisingly, have small average views. So pretty much all these people would be cut out if I did something like restrict it to 100. But at the same time, I guess it depends on the framing of the story, because so actually these are the first ones I do recognize. Roswell Butler, who's a basketball player, and naturally Kate Spade. All right. Well, there's another thing to consider, which is, so I think this helps. I think this is maybe like an OR operator in terms of what to include, because anyone that gets, well, 0.1% of Wikipedia traffic is nothing to scoff at. Anyone that gets, and that's 300, nearly 1,000 page views. That's not nothing. So I think there is something to be said for the max views, even with people that had very low average views. So I think that's definitely something I'd want to include. And actually, the change is here. However, someone like, let's just go a little further. This one, Jared Bannister, who I also don't know. Okay, so it was a relatively small time athlete, it looks like. There you go. Although it had a very high rate of change, what was that, 3,000 times higher, 300,000%. It still only hit 1840, which is not significant. Scream things. So it's a he. If we look at his Jared. So let's see, we hit that 18,000. Must have been this year. Okay, so it was very much a blip and pretty much normalized again. Slightly higher actually, but I don't know like how that would be interesting to the narrative. Though it could be interesting to compare, to get more of a global trend for all notable deaths, but notable death is also a somewhat arbitrary thing. I don't know who compiles that list or how it's put together. So I feel like I would be more comfortable if we did have some sort of quantitative metric for deciding who to limit. Okay. So I think that partly settles it. Let's see. So let's see what we're dealing with. So if we go back to the Explorer, so I think it is interesting to include some people like that. But I don't think the rate is on its own going to be a good way to limit people. I think it actually really just comes down to page views. And the two ways of looking at the page views that I currently have are just their median and their max. We could calculate others like their median post death, their median pre-death. I think those are things that will be interesting when we start actually going into the story. I don't know if those are useful things for just filtering out our baseline sample. So I think I want to find a number that I'm comfortable with, that's meaningful to me, that will filter out people specifically like, I don't know how you pronounce that name, Churul Huda, where they never even got 0.1. 0.1%. They never even got 0.1% of traffic, even though the rate of change was higher. However, this person I probably want to keep because that's 200,000. They were almost. Maybe that's the number. So page views is it's easy to understand, but slightly like if I said 100,000 page views, people can understand what that means a little bit better than if I said 0.1% of traffic. Or 250,000 page views. So I guess let's I want to see like the numbers that we're working with if we play with that, because again, there's no real science behind the notable list. So it actually is, I'm comfortable by even further filtering it. So let's use that as a starting point. Okay. So we don't need to sort it anymore. We've got all these possibilities. So let's go ahead and say, well, let's actually leave that as a file. I'm going to create another one for actually filtering. So let's say git status. Actually, let's run it. So unfiltered. Sorry, unsorted. And let's go ahead and call this filter. Let's call it filter population. And we will, well, actually, we're going to want all of these to be. All right, so this time we're going to be loading our CSV. And all we're going to do is yeah, this is pretty straightforward. We'll clean it. And we'll say data.filter. Now we can create our rules for filtering. So clean, that's good. All right. I'm not doing this right. Oh, this returns a truthy value. So let's start playing around with this. So the first thing I mentioned was, let's look at Explore CSV again. I think like the usually, okay, so usually the simplest methodology is both the easiest to communicate and probably also makes the most sense, because at the end of the day, this is about popular celebrity or popular people deaths, and the whole point is looking at traffic and the trend of the traffic. So yes, there could be a couple weird, interesting outliers where it's like a person that gets 5 views and it gets 50,000 one day, but most likely no one's going to know about that person. And secondly, most people won't care because they aren't in the spotlight. And the point is to use this as a proxy for that. So I think I'm going to look at either max views or max percent traffic. And the rate of change will be sprinkled in there, but that will be more of like a story data point rather than something to help filter out this population. So I think, and again, going with the idea of simple is better, it could either be a number that everyone understands, so it could be straight up like if they hit 100K page views, which I think is probably too low, or it could be like if they at some point hit 0.1% of traffic, which is like a shit ton if you really think about it. And I think that number actually ends up being higher. So the problem with doing it this way is page views do fluctuate, right? Depending on the day, and maybe Wikipedia traffic has changed a little bit over the couple of years. So I'm not as comfortable with this one, even though it's it's easier to grasp. This will be a little more even. They're going to return pretty similar results. So this is a one-liner. So it could be d dot both page views. It's greater than, or sorry, not page views. It's not median pages, because we just care about if they are big at some point. So let's go with 100. Or that's 10,000, 100,000. Yeah, let's start there. And you don't overwrite it, so we'll call it. a file for it. Scripts. Yes. Run filter. Great. That's not gonna work. So we're just overwriting the existing property as a number. Good enough. So now if we look at filtered, let's see, we had 14, 19, and doing it by 100K page views as they're at some point. All right, so I feel like that's a much more manageable size. Hey, and we still get Coco the Gorilla in there. 257, that's somewhat reasonable. Let's just play around with it a little bit. If we did, I mean, I think 100,000 is pretty good. Also, it's a nice number. We could also try like 250,000. Let's see how much it reduces it by. I guess down to 136. Also seems like a reasonable number. That's a lot of page views. So let me just take some notes. So I already forgot what that number was. Do it again. It's 135. K equals 100K would be 56. Let's do it by traffic. It's not in percent format. It's in so 0.1%. So that's 1%. So 0.1%. Maybe that. Start there. Use. All right, that's basically equivalent. So that's very similar to the 250K actually. I'm assuming depending on the data, it might be a little lower. I wonder if we ever get less than a quarter. Here we go. So on that day, it was 235. I wonder, that's probably the lowest. Actually, let's see how low it gets at 0.1%, just out of curiosity. Sort. A, B, D3 dot. 7 dot. Actually, I want to look at the views, max views, be that max views. So 1%, oh, that was the one. How about that? So 235K is the smallest that 0.1% would be. What was the number? It was 130. Pretty much exactly the same as 250K. So if we went like to 0.05%, for like 0.01%, be probably a couple hundred. Yeah, we're up to 460. And that hits us 23,000 page views. Now that's not gonna. What about like 0.05%? Basically half. That's all right. That's 1%. Wait, missing a zero. 228. So that makes sense with a minimum page view of 117,000. Right. 227. All right, so I kind of like those. Sorry, I'm kind of into those numbers. My gut tells me to like go with this one. 0.1% of traffic. I think this is a good pausing place. I'll marinate on it and I'll get back to you with my answer. See you, everybody.